In solving these last two, it can be a bit distracting because what it's asking for isn't something that's typical of what you've seen so far. But here we're being asked to solve for x in terms of z. So what that really means is get x on one side of the equation, get everything else on the other side of the equation, and only combine terms that are like terms. So I'm going to move, first of all, my x's to the right-hand side. So that means I need to get rid of this 2x. So I'm going to subtract 2x's from both sides. And that leaves me with negative 3z plus 4 equals 3x. 5x minus 2x. Again, notice that I can show my work vertically. Minus 20. I want to get x by itself, so that means I need to get rid of the minus 20 with an opposite, plus 20. So at this point I end up with negative 3z plus 24 is equal to 3x. Well, I have 3x's here. That's all this is 3x's is equal to this. So I've solved for 3x's in terms of z, but I now want to get rid of that times 3. I can get rid of the times 3 with a divide by 3. I just have to remember that I have to divide everything by 3. So here I have x, negative 3z divided by 3 is negative z. 24 divided by 3 is 8. So I'm going to end up with plus 8. So there it is. There's my answer. I've solved for x in terms of z. So my answer is x equals, and my answer has z on the other side. Now, I could have actually solved for z in terms of x, and that would mean that I get z by itself and move everything else to the other side. This example here, we are solving for x. Now, what's different about this one is x is in the denominator. X is in the divide position. Well, we can't solve for x when it's in the divide. So there are a few ways we can do this, and I'll show you a few ways. But one way in general is, well, if I have a divide by x and I don't want the divide by x, I can get rid of it with a times by x. Just like I can do with divide 2 and divide 4, I can get rid of that with a divide. So in this case, I'm going to get rid of all the divides. I'm going to get rid of the divide by x, by times x. Going to get rid of the divide by 2 with a times 2. And get rid of the divide by 4 with another times 2. So there's my times 4 to get rid of that divide 4. Now I just have to make sure I multiply all this onto these three terms. I just now have to keep track of what I'm canceling out. Here I've got 1, a divide x times x, that cancels. So I'm just left with times 2 times 2. Okay, and maybe I'll just do this in color so that's maybe a little bit more clear. So my multipliers I'm going to just do as red. And so what I end up left with here is I left with 1. The x's cancel out. I'm just left with the times 2 times 2 plus. The divide by 2 cancels, so I'm left with times by x and only 1 2 that's being multiplied. Here I'm left with a 3. The times by 2 and times by 2 both cancel out with the times by 4, or sorry, divide by 4. So I'm just left with times by x. So I'm just going to clean this up. I can work out my numbers and I can work out my algebraic terms. So that's going to be 4 plus 2x equals 3x. Subtract 2x from both sides. Left hand side I get 4. Cancel out. 3x minus 2x gives me my x. Well, I've actually solved for x. So just double checking here, I should really check my answer because I'm not really sure what happened here. But I have 1 divided by x is 4, so there's my x. Okay, so I'm just going to highlight that. There's my x, there's my x, there's my x. Plus 1/2 equals 3/4. Yep, that's true. 1/4 plus 2/4 equals 3/4. That's going to be correct. So that is the correct answer that I have here. So if I want to get rid of this time, if I have x's in the denominator, I can get rid of that divide by x with a multiply by x. What ends up happening then is that x ends up in a different spot, and it ends up in the numerator here and here, which is what I wanted. Those are much easier to solve for. Oh, I was going to show you one other way we could have done this, and since this is a fraction equation, I'm just going to do this over here. This is, call this number 2. If I have 1 over x plus 1/2 equals 3/4, well, I can make this a proportional equation because I know that those are like terms, and I can just end up going 3/4 minus 1/2, which I'll write as 2/4, and I end up, those go together, I end up with 1 over x equals 1 over 4. And using a proportional equation, I know that 1 to x is equal to 1 to 4. Well, that means that x must be equal to 4. So we could have solved this as a proportional equation as well. But what we're working on is this algebraic strategy of trying to get x all by itself. Okay, so this, although this does work, this is kind of what we're focusing on.